Alright, this is where we left off in the last video. We have the model and the view, and it's drawing whatever's in the model. And we have the controller set up as well, so the user can click somewhere and it'll place a disk. So in this video, we just need to make it a fully functional game now. And to do that, we're going to be creating some new functions. No pun intended. And these functions are going to be doing some pretty complicated things, so we definitely want to design it first. Let's write out some more pseudocode for the click to square function. First, we want to make sure that the user is clicking somewhere where they're allowed to click. And if not, we want to ignore that click. So let's say if the user is allowed to click here, get all of the affected disks and flip them, and then continue doing the rest of this stuff here. Otherwise, we don't want to even do this stuff, right? So let's just have it return out of this function if it's not a spot they're allowed to go in. And one thing we can do to make this even easier on ourselves is to create a function called getAffectedDisks. And if there are no affected disks, that means that they're not allowed to go in that spot. So let's change this around a little bit. We'll create a function called getAffectedDisks. And we'll create a function called canClickSpot. And we'll have a function called flipDisks. Okay, let's just finish this function now because we have the pseudocode for it. So let's just say if canClickSpot returns true, then we're going to get all of the affected disks and flip them. Otherwise, we'll return out of this function before it does any of this stuff. Okay, so let's finish that. Let's do else return. And if you want, we can put that in curly brackets too. But in here, we're going to have to get all of the affected disks. So we'll say var affected disks equals get affected disks. And then we can say flip disks. And we'll just pass in that list of disks that it needs to flip upside down. And when I say flip disks, I mean take a black one and turn it white, or take a white one and turn it black. Okay, so there are a couple things we need to do here though, because when we call the canClickSpot function, this function needs to know which spot we're looking at. So we definitely want to pass in a row and a column, which we have right here. Whenever the click to square function gets called, because they click on one of these squares, it knows the row and the column that was clicked. So we can just pass that information into the canClickSpot function too. Which means this function needs to receive a value for a row and a value for a column. And it makes sense that the getAffectedDisks function would also need to know what values those are. So let's pass them in there too. So this function also receives the value for the row and the value for the column. And something we can do that I think will improve the code a little bit is to just move this code inside of the if statement so that it'll only actually do this if this condition is true. And because there's nothing after the else statement, now we don't even have to have the else statement where it returns out of the function. And one more thing I forgot we need to check is if they click on a spot that's already taken, we immediately need to end this function so that they're not allowed to change that spot. So we'll just say, wherever they clicked, we'll say if disks at row column isn't a blank spot, then we're going to return out of this function so they can't do anything. So if that value is not a 0, remember 0 means there's nothing there. So in the model, we've got a bunch of zeros all over. If it's a 0, it means it's a spot they're allowed to go to. So we're checking if it's not a 0. So we have to do an exclamation point equals 0. Then that means they're not allowed to go there. So let's just return. We'll cut this function short. But if it makes it past these few lines of code, then it will check if it's a valid spot where they can actually flip some tiles over by going there. So we should be done with this function. Let's move down to the canClickSpot function. Let's just add some pseudocode here. Now this function is actually pretty easy. All we have to do here is determine whether or not we'd be turning over some disks if we click on a particular spot. So we can make use of this function below to get all of the disks that would be affected by going in a particular spot. And if that list is empty, it means that we can't go there. So let's say if the number of affected disks by clicking at this spot would be 0, return false, meaning they can't go there. Otherwise, return true. Okay, so let's code that. We can save a quick variable called affected disks, just like we did up here. In fact, if you want to just copy this line and paste it down here, it'll be useful here as well, because then we can say if affected disks dot length equals 0, that means there's nothing in it, we'll return false. Otherwise, return true. There we go. The getAffectedDisks function is going to be the longest and the most complicated, so let's save that for last. Let's do the flipDisks function. This one's pretty easy. Let's write out the pseudocode. Oh, and one thing I forgot to do earlier, see how this function is being given a value, affected disks? This is the list of all of the disks that are going to be flipped. It needs to receive that value here inside of the function declaration. So I'll just say affected disks, and that's a list, of course, right? So let's just say for all items in the list called affected disks, we'll just say if the spot with that disk has a 1, that means it's black, we need to turn it into a 2. And if it's a 2, we need to turn it into a 1. That way it'll draw black where it used to be white and white where it used to be black. So let's say if the disk at that spot has value 1, make it a 2. Otherwise, make it a 1. And let's code that really quickly. We'll just say for var I starting at 0 and going up to the last item in affected disks. Increase I by 1 each time. And then we need to get the value inside of that list. Let's store that in a temporary variable. So we'll say spot equals affected disks at I. Each of the items in this list is actually going to be composed of a row and a column. So let's just say if disks at spot dot row and spot dot column, if that value equals a 1, we want to turn it into a 2. So we can just copy this part and say u now equal 2. And then we can say otherwise, and then paste that in and say u now equal a 1. That's all there is to it. Now the hard thing is we really don't have anything we can test quite yet because we haven't finished this function. So let's do this function, and this is the hardest one, and we'll just do it little by little. I've already written up some pseudocode, so I'll just paste that in here. Okay. So the way that this works is it checks all 8 directions from a given spot where they're trying to click. So it's white's turn here. So if white chose to go right here, this function would need to look upward, left, right, down, and all 4 of the diagonal directions. And for each of those directions, it's going to be moving in that direction until it finds either a blank square or a disk of its own color. So from this spot, when we're checking upward, first we find a black disk, which means we need to keep moving. So we go up one more, and we find a white disk. And that means we're done checking this direction. And all the while, it's keeping track of anything in between those 2 spots. So in this case, it would find the black disk here, and it would add that location, the row and column where this disk exists. It would add that to a list, and it would check every other direction, adding all of the locations that need to be flipped to that list. And then at the very end, it returns that list. So I guess I could add that too. Return the list of affected disks. Okay, so let's start coding this. And let's start by checking towards the right, if there's anything to the right of where we clicked that can be flipped. So we'll say to the right. And then we just need to keep track of everything in between that click and where we end up. So let's make a list. And let's just call this could be affected, because we don't know for sure yet as we're adding stuff to it. We'll only know as soon as we've reached the final place if it's our own color. And in that case, we'll add it to the list that's going to be returned by this function. So let's create that list up at the top. Let's say affected disks equals nothing at the start. And then as soon as we've done all of the checking and stuff, we'll just return that. And if there's stuff inside it, good. So if we're moving to the right, we're going to be iterating on the columns. So let's make a variable called column iterator. And we'll start it out at the spot that was clicked, which is column. And then we just need to add 1 to it until we find either a blank spot or our own color. So let's just say keep incrementing our column iterator until we reach the very last column, which in this case is 8. So let's say while column iterator is less than 8, we're going to increase it by 1. And then we need to check what's at that spot. So we'll say var value at spot equals, so we'll look inside of our model called disks at that spot. We'll say at spot row column iterator. So we'll just check if the value at that spot equals a 0 or if it's our own color. Because if it's our own color, then we're done moving in that direction. And the way that we check if it's our own color is using the turn variable. Remember, turn either equals a 1 if it's black's turn or a 2 if it's white's turn. So in that case, where it's either a 0 or it's our turn value, we're going to stop the loop. So you can type the word break. And we also need to make sure that before we break out of that loop, we check if that spot that made us stop looking in that direction was our own color, then everything in between where it was clicked and that ending spot needs to be flipped. So we'll add it to the list of affected disks. And a really cool way in JavaScript to add all the contents of one list to another one is to use the function called Concat. So I can just say affected disks is going to now equal itself whatever items it already had, but joined with or concatenated with all of the potential ones that we stored in could be affected. And this list gets populated inside of the else statement in the case where it's not a 0, meaning it's not a blank one, and it's not our color. So that means it has to be the opposite color. So that's going to get added to could be affected. And we'll just pass in a variable called disk location or spot, whatever you want to call it. But we need to create that variable here. Disk location is going to be an object with 2 attributes. It needs to have a row value and a column value. So we'll just say row is equal to that row right there. Because it's the same row. If we're checking toward the right, the row is always going to be the same, so we'll just pass in row. And the column is the column iterator value. Okay, so we should be able to test that now. So remember, what we're testing here is if we can click somewhere where we can flip tiles to the right of us. So in this case, if I clicked here, it would flip the white one because that's to the right of me, right? So let's click there. And it looks like it works. So this code right here, you can actually just copy and paste it 7 times and change it so that it looks in all of the other directions. And one thing I just realized is when we're looking to the right of the spot that was clicked, we don't want it to check to the right if they clicked here. So that would be at index 7 because we've got column 0, column 1, column 2, column 3, column 4, 5, 6, 7. So we'll say only go up to 7. While it's less than 7, we can continue checking things to the right of us. Okay, so that should work to the right. And let's copy and paste that, and let's now make it work for the left, moving in the left direction from where we click. So let's change a few things here. What has to change? Well, instead of checking if it's less than 7, now we want to check that column iterator is greater than 0. And we also, instead of adding 1, which moves us to the right, we want the column iterator to subtract 1, moving to the left. And that should be it. It should work now. So we should still be able to go here, which is checking to the right of us. And if we wanted to test whether we can go to the left, let's just refresh it. And if we wanted to check to the left of us, we could click here, because we should be able to flip this one. And it looks like it works. Good. Okay, let's make it work for the up and down directions now. So let's just copy this. And let's say above. And instead of dealing with columns, now we're dealing with rows. So let's change this name to be row iterator, and change this to be row. Change this to also be row. And because we're checking upward, the top row is a 0. So while the row iterator is greater than 0, that's still the condition we want. Change this to say row iterator, subtract 1 each time, and we're good. These need a change, because now we're dealing with the row iterator as a row, and the given column as defined by the click. And then do the same thing down here. Row iterator, and then just plain column. Okay, let's test that. Now it should check above wherever we click to see if there's anything to flip. So this spot should flip this white one. And it looks like it works. Okay, let's make it work for downward as well. So let's copy that. Change this to say below. And we're still dealing with the row, which is good. But we need to change this loop condition so that it's not going upward, it's going downward until it hits a high value. So its max value it can be is a 7. So we'll say while it's less than a 7, check downward by adding 1 to our row iterator. And that should work now. So I should be able to click here, and it'll check below me to see if there's anything to flip. And it works. So we should have all 4 directions working now. If I click here, it flips that, and then white can do the same thing. And if I click to the right, it'll flip that one. If I click to the left, it'll flip that one. If I click below, it'll flip all those. If I click below for this guy, it'll flip that one. Now we just need to make the diagonals do the same thing. And checking the diagonal directions is almost the exact same process. We just have to have both of these be iterators. Because if you think about it, when we were checking to the right of wherever we were, the column is the only thing changing. The row stays the same. But if we were to check diagonally down to the right, each time we iterate to a new spot, we have to change our column to increase by 1 and our row to increase by 1. So that would put us there. And then increase them both again, that puts us there. Increase them both again, that puts us there. So let's do that. Let's try making it work by going down to the right. I paste in the one that's checking below, and I changed it to say down right. And I need to have 2 iterators now. I need to have a column iterator as well. And that's going to be initialized to have whatever the column they clicked on was. Okay, and then we also need to change this while condition so that it's checking if the row iterator is less than 7 and the column iterator is less than 7. Because it might be able to increase a row, but if it's already out here, we can't increase the column anymore. So both of these need to be true in order for us to continue checking that spot. All right, so in addition to increasing the row iterator, we'll increase our column iterator each time. And then we need to use the column iterator to check that index. And then we need to change column to say column iterator there as well. All right, let's test that. Let's see. If I go here, I guess right here, it's white's turn. So checking down to the right, it should be able to flip that black one. So let's test this. And it looks like it works. Awesome. Okay, let's try down to the left. down left. We still need both iterators, but this time the column iterator, instead of checking if we're meeting the right border, we need to check if we're meeting the left border. So we don't want to check if we're less than 7, we want to check if we're greater than 0. And we don't want to increase our column, we want to subtract from our column. We want to decrease it. So let's test that. If I go there and there, I should be able to click here because it's black's turn, and it should check down to the left, and it should be able to flip this one. So let's click here, and it looks like it works. Good. Now let's do the upward diagonal directions. So I can copy that, change this to say up left, and then later I'll do up right. So if I'm changing it to be up to the left, then my row is going to be decreasing, and the column is also decreasing. The while condition for the row is going to be checking as long as it's greater than a 0, just like the column is checking if it's greater than 0. So it's moving up to the left. And that should do it. Let's test now. If I go here and here. And now I can test by clicking here if the up left direction works, because it should be able to flip this one. So I click there, and it looks like it works. Good. And the last direction we need to check is up to the right. So I'll change that to say up right. And the only change we have to make here is increase the column iterator instead of decrease it, and make it so that the border it's looking for is on the right. So if it's less than 7, that means it's not in that column. So now all the basic functionality of Othello should be here. We should be able to go up, and it flips that tile. We should be able to go up for this guy, it flips that one. We can go to the right, we can go to the left, we can go diagonal, we can go diagonal here, we can go diagonal here. It looks like it's all working, which is great.